Hey, hopefully you're watching this. It's Wednesday, the 10th of March. We're going to take a look at the Desmos from today so that you can check in on your answers and really move to the best of your ability. I hope I have my sound on. Yeah, I should. Okay. So I'm going to just try to make this a little bit bigger. All right, there we go. So we're looking at the do first, and you're going to put these in pairs depending on the words or the image that you see going through this. So you know what I like to do? I like to spread these out so that I get a little more space for myself. And then I'm going to start with all of these different ways of describing the sequences. So I have these sequences. Here's a description. I don't think they match up with each other, but we'll go through. So it says this sequence starts with 30 and decreases by 4 each time. So I'm going to look. Here's one with 30, decreases by 4 each time. Nope, that's going down. Looks like a division. Okay. Let's see. Here's 30. Oop, that's going up 4 each time. So, okay. Let's see another one with 30 in it. Oh, starts with 30 and it's going down by 4 each time. There we go. And that's the recursive form of that linear function. All right, right here, the sequence starts with 30 and each term is 1/3 the size of the previous term. Hey, we saw that, right? Dividing by 3 is the same as multiplying by 1/3. So this is a geometric sequence. Let's see, a sequence that starts with 3 and whose fourth term is 24. So 3 and fourth term is 24. So here's 3. Oh, but there's no way the fourth term is going to be 24 because that's going down. Here's no, that's 30. Here's 3. The fourth term, though, is already 27, so that's not it. This one starts with 3. The fourth term, I'd multiply 2. So the first term is 3. The second term would be 6. 6 times 2 is 12. 12 times 2 is 24. Hey, that's it. Boom. This sequence only has one positive term. Okay, so let's see. If I start with 2 and multiply by 1/2, that'd be 2, 1, 0.5. Oh, so there's more than one positive there. In fact, they're all positive. Here I start at 3 and I multiply by 1/2. Same thing, it's going to all be positive. Here I start with 2 and I subtract 2 each additional term. So 2 minus 2 is 0. 0 minus 2 is -2. Hey, so 2's positive, 0 is not positive. It's actually neither positive nor negative. Then -2. So this one only has one positive term. Boom. All right, and then let's see. Let's take a look at this. This says 130, then 234, 338. So from 30 to 34 plus 4, 34 to 38 plus 4. Okay, so it's increasing by 4 each time. Where did we see that? Oh, right here. Starts at 30, increases by 4 each time. So those two match. Nice. And now I have, oh, I'm hiding one here. A sequence whose term increases by 8 each time with a starting value of 3. Oh, so this one starts at 3, but that's multiplying. This one starts at 3, but that's decreasing by 1/2. This one starts with 3 and it's going up by 8 each time. There we go. And then I have these two. Well, this should be easy, right? Because this says the first term is 2. This one says the first term is 3. So boom, first term 3, first term 2. Let's double check. Multiplying by 0.5. So 2 times 0.5 is 1, times 0.5 is 0.5 times 0.5. Yep, that works. This one's multiplying by 1/2. Oh, so the change is exactly the same, 0.5 and 1/2. So 3 times 1/2, 0.75. Half of $1.50, 75 cents. Half of 0.75, 0.375. Awesome. So we did it. Check your answer, see how you did. Took me about 4 minutes. So see how long that takes you. All right, so we're going to walk through the rest of this here today so that you can assess yourself and take a look. Each of these have a checkbox, so we'll do a couple of them and then I'll make sure you're doing the rest. Read these instructions, right? If it's increasing, right, we're going to add that percentage to 100. If it's decreasing or decaying, we're going to subtract it from 100. And then we need to turn that percentage into a decimal. All right, so this says the rabbit population increases by 34% each year. So to increase by 34%, right, we're going to say that would be 100%, and it won't let me do this on here. So 100% plus 34% would give us 134%. But what would that look like as a decimal? Right, 134%, move that 2 spots, you get 1.34%. All right, pause that and see how you're doing. All right, so let's take a look at these next two. I'm going to grab a snippet here, bring that to the screen with me. I'm looking up at my upper screen, so if my eyes aren't staring at you, you know why. So when we look at this here, it says each day you lose 20% of what you learned the day before. One, that's scary. Two, also very true. So if we lose a percentage, right, we take 100% minus 20%, and we should have 80%. But then how do I turn that into a decimal? 80% becomes a decimal by moving the decimal spot 2 spots, right, dividing by 100, and so we get 0.80, which we could just write as 0.8. Both are the same. All right, the one below it, it says the median household, right, the median household income in the U.S. increased by an average of 0.05%. Increased, so we're adding to 100%. Oh, sorry, I did that wrong. 0.5, not 0.05%. And so that's still a percentage. So we add those together, we get 100.5%. Now move that decimal spot, divide by 100, right, 1, 2, and we get 1.005. You should get green check marks here when you get these correct. All right, go ahead and go back to those and try the rest of these out. All right. So now let's take a look at Dr. Larson here. So Dr. Larson is contemplating the impact of an antibiotic on a particular patient. The patient will take 820 milligrams. Every hour her body will break down 20% of it. Does breakdown seem like growth or decay? Yeah, it seems like decay. It's going to decrease. So write an explicit equation modeling this situation and decide how much antibiotic will be left after 2 hours. So let's go ahead and work on that together. You're going to have to type these in. And so remember our explicit equations, right? F of x equals our starting value times our growth rate, our common ratio to the x power. So they give us our starting rate here is 820. And now it says it's going down by 20%. So how do we find that? 100 minus 20 gives us 80%. We just did that, so it should be 0.80 all to the x power. And so you can write that equation in there. F of x equals 820 times 0.8 to the x power. Now if we want to find out how much it is after 4 hours, we're just going to create this equation, 820 times 0.8 all to the 4th power. And if you notice, we can do that right in here. 820 times 0.8 all to the 4th power. And it says 335.872. What would that be? We look back here, it's milligrams. So if you start with 820, after 4 hours, it's down to 335. That's how medication wears out, right? All right. So now we have these two pieces here. Go ahead and read through these. And again, you're supposed to do these on your own. I'm not going to do the test for you, so you need to do these on your own too. All right, so pause it. Go ahead and I'll give you these answers when you come back. So how'd you do? Again, filling out this table, you should have started with 1. It gives you 8. Right? That's the first term. So it should be 1/8. Then to go down, you're going to subtract by 5 each time. Go back up by adding 5 to get your y-intercept of 13. So when you write this explicit equation, you should have a sub n equals negative 5n plus 13. Did you do it? All right, so go ahead and try this one again. I'll be back. Wow, did you just watch me do that whole thing? All right. Well, if you did, now you know how it goes. All right. So again, the same idea. 10 is our starting point. We're going times 2 times 2, and then we're going all the way up to our first one. So if we're multiplying by 2, we're going to divide by 2. We get our initial value is 5. Our growth rate is 2 to the x power. Boom. Let's see. So now you have all these to try out on your own. Give them a shot. Come on back. All right, so that was a bunch of them for you to try, so you're going to have to walk through this. If you have one wrong, go ahead, ask Mr. Winter. All right, so problem 1, I got a of 1 is 4, and then a of n plus 1 is a of n plus 4. That becomes 4x plus 0. You don't have to have the 0, but you can. Look at this next one, 4. And then it's a of n times 2, right? It's being multiplied by 2. So then we have to go backwards to get our starting point of 2 times 2 to the x. Here, all of our information is given. So 0 gives us -1. Boom. Again, see where that -1 shows up here in our explicit? And then plus 3 means 3x minus 1. Again, you can pause and go back and get that down. And then finally, well, there's 3 more left, right? A of 0 gives us 4, so that's right there. Oh, it shows up right there too, right? Our our y-intercept shows up. We're multiplying by 1/2, so our explicit function's 1/2 to the x power. All right, this one was fun, right? Going up by 3 each time. Stage 3 has 11, and so the next one's going to be plus 3. Well, that means it's 3x. We have to find our initial value, so we go back to stage 0, subtract 3, we get 2. And this last one, we have 2, 4, 8, 16, so we're multiplying by 2 each time. Our ace of 2 is right here. That's 4 blocks. If I divided by 2, I would get 1 block in figure 0, so that's 1 times 2 to the x power. Go back and check those, make sure you got them right. Taking a look at this last question, take a pause here and dig in. It's not letting me pause. Why not? So how do you do on slide 13? Again, remember you can click on these values and find each of them. So you should have started here with 116, and then as you plug these in, hopefully you're seeing you're going down by multiplying by 1/4. All right, so if you look here, if you describe it, the sequence begins at 1 and decays by 1/4 each term. I wrote out those terms for you so you can see them. And then I reminded you, we need to multiply, right? We need to go backwards to find our 0, right? When our input is 0, because we need that for our explicit function here. And that is written there. So hopefully you nailed it. Good luck. All right, so let me know how you're doing. All right, send me any messages that you want to talk about the assessment to get tomorrow. And then here is an optional Delta Math that you can review everything in Chapter 4. And let's rock this, okay? Have an awesome rest of your class and your rest of your day. And please check in with anything that you need help with.